I wanted to talk about ML prepared this awesome thing, awesome model, data science so I got a notebook and a file. Cool, let's now deploy it in a way that it's, production ready and makes sense so people can actually use it. So I'm a big fan of Kubernetes, hence the big logo. So, and we also have I'm part of Kubeflow community, and we have a couple clusters on GKE that we can use. So we decided to just deploy it in Kubernetes. So Hamel prepared the Flask application that will do inference, cool, but Flask is not very fast, as Hannes before mentioned. However, I told not to worry, because there's a way with Kubernetes and with cloud in general, and that's pretty much at more of them. So one thing I want to mention is that we have 9, 8, a lot of them of Flask running the same thing, really. And it's since each will be kind of slow, but will take only 1/8 of the whole traffic, it's okay, and we can always add more. It's a one number to change. And Kubernetes makes it extremely easy. So yeah, that works. We have an API. It's available, as you saw before. So now let's figure out how to do the same thing to data processing and training. So I'm a big fan of another technology called Dask. You may have heard of it, because I like pandas, and pandas is not parallel. So let's add more cores to pandas, or actually more servers. So right now, I think we have 10 nodes of Dask. It will have a couple cores, so we have 130 cores at our disposal. Because Hamel, when we told me, how you did the pre-processing, and that's 3 million of issues, and each issue is long text, so it's pretty high dimensionality data. So how much? He just spawned 100 core VM. Cool. Not everyone can spawn 100 core VM. So Dask allows us to actually achieve a little bit better performance in a way that instead of having one huge VM, we have now multiple VMs that are regular. It's actually cheaper this way. And yeah, it's really cool. If you need power to parallelize your pandas, awesome. And I hope you kind of see the pattern here. I'm coming from cloud environment, cloud background, and a good way of thinking of of your application is, if your application is scalable, that means that you can add more of it if it becomes too slow. So if you design your application in a way that it will be horizontally scalable, you will be in a very good place. So yeah, and if that would be too slow, we can always add more. That's the big thing. If we want to extend our data set, we can always add more nodes. So next step will be, okay, so we already have the code that will do one training, but now we can do, we can always train. We want to just, one click and train and pre-process the data and train the whole model with Dask, with everything. And that's when another cool project calls in, that's Argo. And Argo runs on top of Kubernetes, and it's this kind of a DAG. It allows you to generate DAGs, and that will also have additional functionalities like artifacts that are saved to S3. And this is particularly not very complex pipeline, but that's the pipeline we used for this, but it can go as complex as you want, including loops and stuff like that. So Argo is another great tool to use. And yeah, so that was our weekend project. So there are a bunch of stuff that we can improve, and that's just a couple of things that I can think of top of my head. First is distributed training, because I like the add more philosophy. So right now we only train on a single node, but with TensorFlow 2.0, the distributed training, multi-node training is actually much easier. And I would encourage everyone to try the distribution strategy and dig into distribution strategy of TensorFlow 2.0. It's really great. Automatic hyperparameter tuning. It's something that we just started to develop this Friday, and it's an open source, so at some point it will land in this repository when we want to use Argo to also automatically perform grid search of hyperparameters, or maybe later hyperband or even neural parameter search. And yeah, finally retraining our data and maybe move, like, because we can always add more flasks, but if we move to like more performant inference servers, like TensorFlow serving, it will be awesome. Thank you.
Awesome. Thank you, Mihal.